Nikhil has been observing tiny particles today. What happened was, he choked on his food and started coughing. So, his mother gave him a piece of rock candy to suck. He thought it was too big, so he tried to break it with a pestle or a batta. And what Nikhil saw was so many particles. So, Nikhil decided he just had to find out which other things can be broken into particles like the sugar candy. He pounded a piece of coal and saw it broken into particles. When he banged the blackboard duster on the windowsill, he saw particles of chalk in the chalk dust. He saw a piece of wood being cut and noticed the particles of wood in the sawdust that was falling down. Have you all ever had the chance like Nikhil to see or think about particles? Or you might have seen fine, shiny particles of iron or copper produced when iron or copper is cut with a hacksaw. All substances like pencil, chalk, paper, wood, grains of wheat, iron, copper, coal are made up of particles. These small particles that we can see with our eyes are themselves made up of many smaller particles. But those particles are too small to be seen by our eyes. We can see the piece of rock candy. We can also see the tiny particles that we get on pounding. But do you know? Lakhs of tiny particles must have come together to make that bigger particle of candy that we can see just with our eyes. It was Maharshi Kanad who stated that all substances are made of particles. He said that all the things in nature can be put into 4 groups and everything is made up of particles. He named these particles pilav. If you carefully observe a sunbeam, you will see particles of dust floating in it. There are also many smaller droplets of water in the spray we get from a fast-flowing stream of water. This shows that liquids are also made up of particles. We place naphthalene balls in woolen or silk clothes. After some days, these clothes begin to smell of naphthalene. Have you ever wondered why? The naphthalene balls are constantly forming small particles of naphthalene in the gaseous state. These tiny particles settle on the clothes and the clothes begin to smell of naphthalene. So, here also we see the phenomenon of particles. You must have noticed how naphthalene balls grow smaller and smaller in size over time till they completely disappear. Now tell me, what do you see here? Right, this is water. Now, what is this? Right, ice. But it is also water, isn't it? And what is this? Yes, that's steam. Steam is water in gaseous state. In solids, particles are very closely arranged. That's why they have shape and they are stable. In liquids, particles are arranged little away from each other. There is space between them. That's why in liquids, they are not stable. So you see, water exists in 3 forms or states: solid, liquid, and gas. Even when the state of water changes, the particles of water in each of these forms remain the same. Now, you might be wondering how water can be in 3 different forms if the particles remain the same. The answer is in the way in which particles are arranged in each of these forms of water. The arrangement is different in each of these forms. In solids, particles are very closely arranged. That's why they have shape. They are stable. In liquids, particles are arranged little away from each other. There is space between them. That's why liquids flow. They are not stable. In gases, the particles are far away from each other and moving fastly. They are not at all stable. Thus, we see that water changes its state and there are differences in the properties of ice, water and water vapor. By properties of a substance, we mean its color, smell, taste, whether it is transparent or opaque, soluble in water or not, etc. So you see, every substance in nature is made up of particles and also that it exists in a particular state. Depending on the properties it shows, we can tell whether it is in the solid, liquid or gaseous state. So, we can say that aluminium, coal is in the solid state. Kerosene and petrol are liquids, while nitrogen and oxygen are gases. Now, have you ever thought about what difference there might be between a substance and an object? Think about it. Suppose you have gone to shop for an earthen pot for water. What do you think about? Yes, its shape. Is it round or not? What else? What is it made of? Some like a red soil pot, some a black one, isn't it? Now think, the substance, soil, has been used to make the object pot, right? Objects have a particular shape. Their parts have been put together in certain way. That is, they have a particular structure. Objects are made from substances. So let me see. Can you tell me what substance these things are made from? You are right. All these things are made from wood. Another very important use of substances is that they can give us energy. What is energy? Energy means power. Heat, sound, electricity are common examples of energy. Energy exists in the form of waves. Energy is also the capacity to do work. A car or truck gets the capacity to do work when it gets energy by burning petrol or diesel. If the petrol is finished or if it stops burning, the car cannot move. It means that energy is obtained in the form of heat by burning. We get energy in the form of heat from several substances such as coal, diesel, LPG, CNG petrol, etc. These substances are called fuels. Many appliances and machines can be run on various kinds of fuels. Do you remember learning that energy is produced in our body by the burning of certain substances? Thus, we see that we also need energy to work. When a person or a vehicle is running, the energy is used. That is, heat energy is used to produce motion or movement. Energy in the form of motion is called kinetic energy. All moving objects have kinetic energy. The blades of a windmill turn due to air in the motion, that is, wind. Wind also causes a sailing boat to move. This work of the windmill and the sailing boat is only possible because of the kinetic energy of the wind. Look at this fan, or a mixer, or a pump. Work is done by all these appliances due to the kinetic energy in them. However, they obtain their kinetic energy from electricity. It means that electricity is also a form of energy. Let us now learn about some other forms of energy. All appliances do not run on kinetic energy. They run on other forms of energy. For example, we use electrical energy for running a TV. In the TV, we use electricity. Electric energy is converted into light and sound energy. Like from electricity, we get energy from sunlight too. Plants use sunlight to produce their food. In this process, The sun's energy is stored in the food they produce. These are the foods that our body burns to obtain the energy it needs for doing work. That's not all. Nowadays, we are also using the sun's energy in solar cookers and solar water heaters. When we burn fuels like coal or oil, the sun's energy stored in them is converted into heat energy. Thus, we use various forms of energy, namely heat, light, sound, electricity, and kinetic energy. But we must always remember that the stores of coal and mineral oil on earth are limited. In the future, we will have to use solar energy or nuclear energy for producing electricity. Similarly, wind and water are also never-ending sources of energy. We must use them as sources of energy as much as possible. What did we learn? All substances are made up of minute particles. We can use substances to make many objects. Substances exist in the solid, liquid, or gaseous state. We get energy from certain substances. The capacity to do work is called energy. Energy means power. All things in motion have energy. We use various forms of energy such as heat, light, sound, electrical, and solar energy to do different types of work. Coal, petrol, etc. are limited sources of energy. Water, solar energy, wind are never-ending sources of energy. Exercises. What objects do we make from each of the following substances? Make a list of 5 for each. Soil, wood, stone. What do you think are the reasons for the following? Your friend is washing his or her feet under the tap. You are standing behind him or her, yet your feet get wet. Ice remains where it is placed. Water flows. Water vapor rises into the air.